Let's get this started. Thank you for taking the time to come and see the Platform 9 presentation today. The presentation is titled A Not So Extreme Makeover. Discover the private cloud that's already existing in your existing virtualized infrastructure. Very quickly, I want to introduce myself. I'm the co-founder and CEO at Platform9. Before starting Platform9, I was an engineer at VMware. I helped build a lot of the VMware products that you use. vSphere, Update Manager, Site Recovery Manager, vCloud Director are some of the products that I've worked on. And I co-founded Platform9 with three other early engineers from VMware. So we have a lot of very good understanding of the virtualization industry and the challenges that customers face. The overarching thesis around today's talk is around private cloud. So just want a quick show of hands. How many of you have a private cloud already running internally? Kind of one, kind of two, okay? And do you feel that that's competitive with public clouds and managed clouds today? Yes, a no and a yes. So I want to just quickly define what a private cloud is for the purpose of our conversation. I think the first tenet in a private cloud is that virtual machine provisioning, workload provisioning, is extremely streamlined. So you need to start with a central library of golden images that are highly curated and very, very well defined and maintained well over time. And they're a minimal set. You don't want this to be a sprawl. You need this to be a well-known curated set of images that are used as a basis for workload provisioning. And you then need to have standardized configurations of resources that are made available to workloads. So when you go to Amazon Web Services, for example, there's a concept of a flavor which defines what CPU resources, what memory resources, what disk resources a workload receives. So I think that's a resource configuration constraint. And then you need to have a way to define groups of users and their association with organizations, quotas and policies around the resources that are made available to those organizations. So when you have all of these together, you have a library of images, you have virtual machine flavors which define resource configurations, and you have ways to map those to tenant organizations, users, quotas. You have a way to streamline VM provisioning as opposed to having a very ad hoc VM provisioning workflow. So this is a fundamental building block that you can use to deliver a self-service infrastructure. Because if you have all of these, you have what it takes is the core basics to deliver self-service to the users and developers within your organization. And if you have self-service, you can now start to do more advanced automation with APIs. Not everybody may want to use automation using APIs, but some organizations might. For example, a lot of the usage in the public cloud is developers using automation tools like Boto on Python, tools like Vagrant, Packer, and the libcloud and jcloud integrations to automate their dev, test, build pipelines. And that's a possibility that you can now have if you have some of these fundamental constructs and a useful API that makes these capabilities available to the end users. Not only basic API automation, but you can start to do more advanced automation. So for example, 5 years ago, there used to be a way of protecting VMs, and it's still very popular for legacy applications called VMware HA. And it's a very good feature that's very relevant to any application that doesn't have a horizontally scalable design. But if you have an application that's horizontally scalable, as a lot of new applications are, then VMware HA is not enough, because horizontally scalable applications need a different kind of HA. You need the ability to scale up as your capacity runs short and scale down when that capacity is not being utilized. And availability is provided by having a large number of worker nodes as opposed to an individual machine that you want to keep available. So this is an example of an automation workflow that you want to be able to perform with a cloud platform that you may not be able to do with a traditional vSphere deployment. And that's just one example. There's lots of such examples of automation workflows. The point being that you start with a streamlined workflow of VM provisioning, and you build up self-service, API-driven automation, and more advanced automation sequences to the point where you transform the culture from being one where you provision VMs individually, to you build a library, a growing library of automated blueprints. And you move your organization's culture from being one of deploying VMs, point and click, to an organization that is more DevOps-like and is contributing and maintaining a library of automated blueprints. So that is really the potential that a private cloud framework can deliver for you with the infrastructure that you already have. So, with that said, just pointing out the value is when in the 1990s, infrastructure was possibly primarily physical hardware, and it wasn't very high business value, and you didn't need a lot of skills to necessarily run physical hardware. Virtualization changed that. With virtualization, you could start to deliver better agility. Provisioning of virtual machines was faster. Provisioning of resources was faster. Development teams often did not need to wait on resources because you could use resource overcommitment in vSphere to provision workloads faster. But the skill level that was required from an IT operations team also increased. And private clouds really take that to the next level. The idea is that a private cloud is the automation nirvana, right? For an organization, an enterprise, using the infrastructure that you already have, it gives you the ability to automate cradle to grave all of your build, test, stage, deploy, tear down. The entire life cycle is automated cradle to grave, and the culture moves to one of primarily an automated and self-healing environment. That is really what a private cloud can enable over time, and it does require more skill to get there. You need an infrastructure that you can run and support, and there's some well-known challenges with that. But you also need the ability to transform, I think, a culture of system administrators to be more automation-oriented folks, right? So Platform9 was at Amazon reInvent recently, the conference in Las Vegas, and we had the survey that asked customers, what are your top concerns? Right? So private clouds have all these features and benefits. What are some of your top concerns with private clouds? So I just want to focus on the top three. If you look at it, it comes down to operating costs, complexity, and the skill set that is required to run a private cloud, right? So it's all about essentially, in a nutshell, the complexity. So what if I told you that before we end this presentation, we have about 20 minutes left, I will show you how to go from a VMware environment to a fully production-grade private cloud live with a demo before this meeting ends. It does not need to be complex, and I think that's the key insight behind Platform9, because of which we started the company. So our mission is to make private clouds easy for the enterprise, and we want to make that easy using open source, being interoperable with the infrastructure that our customers have. And I'll very quickly outline the solution and actually spend some time with the demo. And actually, I'd love to make this interactive and take some questions as you have them. But very quickly, Platform9 is in deployment. We're now 2 years old. We're a startup that's well-funded by Menlo Ventures and Redpoint Ventures. We're in production globally. We're all based in the US. We have no employees outside the US. But we do have customers globally. And some of that has got to do with the design of our system, as you'll see in a demo. We're based on Openstack. Now, why Openstack? Here's why. Openstack is the only open alternative to Amazon Web Services. You can either play in Amazon Sandbox, or you can play with an open source community that is building an equivalent to Amazon's Web Services framework and is more interoperable and friendly to the infrastructure that enterprises have and want to use over time, right? So that's why. So essentially, if you look at the design of Openstack, there's an identity access management system, there's a compute system, there's an image library, there's a networking system, there's a storage system, there's an orchestration system, there's command lines, APIs that are functionally and conceptually very similar to Amazon Web Services. It's open source, so there's no one vendor that kind of drives it. And this layer, even though most people imagine that OpenStack is used only with Linux, this layer fundamentally is independent of your virtualization platform. So you can use this with vSphere. And today's demo, I think most of the audience here is more of a VMware background. So I'll actually do a demo with VMware. And I'll show you how easy it is to go from a vSphere deployment to having OpenStack orchestrating that very quickly, right? But that's essentially the value of OpenStack. It's an open system. The API is interoperable. There's lots of integrations with storage and network and programming libraries that integrate with the OpenStack API. So our solution, Platform9 solution that makes private clouds easy is called Platform9 Managed OpenStack. The idea is that we eliminate the complexity associated with private clouds by delivering OpenStack as a service. It's a completely managed service and like a SaaS service. So what that means is that your servers continue to run where they are. Could be on premises, could be in co-located facilities, could be leased from a managed service provider, and we're agnostic to that. And this is your own dedicated cloud platform that you can just sign up and use with your existing servers in a matter of minutes. And it's agnostic to whether you run Linux or VMware, and we just focus on making you successful with your private clouds, right? So I'd like to, actually I have some architecture slides, but I want to show you a demo. So this is a live environment that we're looking at. And this is a vSphere environment, as many of you are familiar with vSphere. And what I'm going to do is I'm actually going to show you a Platform9 environment that is, everything okay? So this is a Platform9 environment that I'm going to use. It's an OpenStack control plane that I'm going to use to orchestrate that vSphere environment right now. So the first step in Platform9 is to actually add a host. And that's the one step that I've already staged in the interest of time. The way Platform9 works is that you can download an agent. So OpenStack is running as a SaaS solution, okay? And it interfaces with your server infrastructure, wherever that is, using agents, which help to interface between your server capacity and the OpenStack control plane. So in the VMware case, that agent is made available as a virtual appliance. So this is the virtual appliance that you see. You see the link at the bottom. It's an OVA. And in the interest of time, I have already deployed that virtual appliance here. And you can see that it's running. It's taking very little resources. It's a very lightweight virtual machine. And this virtual appliance, when I deployed it here, is communicating with the vCenter server that I deployed it to. So it registers to vCenter and queries the clusters and data stores, okay? So that's where we're picking it up. It's a standard virtual appliance. You just download it from your account and you deploy it in vCenter, and that's where we're picking up the demo live. So I'm going to go back into the Platform9 UI, and you see that the appliance has gone back to the OpenStack control plane and is requesting authorization. So we're in step 2. So I'm actually going to go ahead and authorize that host. And you see that there's a message saying there's a newly added vCenter gateway that's awaiting authorization. So let's go and authorize this appliance. You can see that there's clusters, data stores that it's seeing. These are the clusters. If you notice vSphere, these are the clusters that are actually being managed by vSphere. So that appliance, when you deployed it, it went to vCenter, queried the clusters and data stores that you have, and went to your OpenStack controller and said, I'm here, please authorize me, okay? So I'm actually going to select a couple of clusters, and for each cluster, you need to give it some storage capacity as well. So I'm going to select a couple of data stores for each cluster. Now, remember that we spoke about having the streamlined VM provisioning requires a centralized image library. So OpenStack has a project called Glance, which serves as the image library. And what I'm going to do now is I'm going to configure my OpenStack Glance image library. I'm going to do that by just pointing it to an API endpoint locally, an IP address where the API is going to be available, and a vSphere data store where the templates are going to be available. So I'm going to say that this data store is now the repository of standardized templates that my cloud can access, and I'm going to select that. So let's give the Glance data store an API endpoint. So this is the first one. And one of these data stores that we've selected needs to be selected as the backing. So I'm going to choose this particular data store as the backing for the OpenStack private cloud image library, okay? So to review, we selected 2 clusters. We selected at least one storage node for each cluster, and we selected where the virtual machine images, the golden images, actually live. Now, this process is happening live. This is a live demo, folks, so if it fails, you know it's real. But it's going to take about 2 or 3 minutes to complete. And while that happens, I want to just show you the architecture that we're using. So let's go back in here, and we'll come back and check on that live environment. So the architecture that we're suing is there's a vCenter environment that represents an already existing vSphere deployment that many of you already have. And there's an IT operations group that is trying to make it more efficient by delivering streamlined provisioning, self-service access, API-driven automation, build pipeline automation, all of that stuff, all of that good stuff. And the way Platform9 comes in is that we host the OpenStack control plane. So every customer gets their own dedicated OpenStack control plane. This is not shared across customers. So you get your own controller that you can lock down to be only visible from your organization's networks. And then we deployed that Virtual Center gateway. So this is a gateway appliance that interfaces between vCenter and the OpenStack control plane. It serves as a proxy. So because the controller is running as a SaaS solution, and the appliance binds to vCenter, it queries the metadata from vCenter, it queries the clusters and data stores that are available, and it's going to make those metadata snapshots available to the OpenStack control plane, and it does that every 10 minutes. So it essentially keeps discovering what's happening in your environment, and that metadata, what is the compute capacity available, memory capacity available, network capacity available, is made available to the OpenStack controller, which is where we went in and we authorized some of those resources and said, OpenStack, you're now allowed to orchestrate some of these resources, and now you can define users and tenant organizations, and those users in turn can then log in and deploy VMs from the curated set of images that we have in the image library. They have self-service access. When they perform those operations, all OpenStack is doing is it's orchestrating those operations via the vSphere gateway. So the actual operations get done in vCenter. So to recap, the control plane, Platform9 owns it. We deliver it with an SLA. We back it up. We monitor it. We set it up. All of the heavy lifting, the complexity around OpenStack, we deal with. The API proxy, the vSphere proxy, is a very stateless, lightweight virtual appliance. You can destroy it and build it again, and it makes no difference because there's no state in the virtual appliance. And the actual VM operations are happening in the vCenter layer, right? So that's the architecture. So let's go back and take a look at that live environment that we kicked off. And this can take a few more minutes. We may need to give it a few more minutes to come back. And we'll come back and take a look at it in a few minutes. Some of this will start to converge a little faster than others. And we may need to give it a few minutes to come back and see it. So any questions, folks, at this point on the architecture that we reviewed?
So the vSphere, do you require certain edition to work with your software?
So the question is, do we need a certain edition of vSphere? The answer is that you need to have DRS-enabled clusters. But we could work with vSphere standard as well. So it's vSphere 5.x, vSphere 6.x, 6.0. The edition, we do require DRS right now. That's a prerequisite. You need to be running clusters that have DRS enabled on them. But that is something that we could simplify if needed. So that's what we need today. But we also support plain old Linux. So you could be just using this with Linux servers where we'd be using KVM as a hypervisor. So we are agnostic to that. Any other questions on the architecture? That's correct. So we already support for both vSphere and KVM is generally available, and we are having early access support for Docker, which we're actually going to be orchestrating with Kubernetes. So and I think generally Docker is a little early, so it's not going to be available for a few months, but both Linux and with KVM and vSphere are generally available in the product today. So the key benefit of Platform9 is that the challenge, the complexity, remember what we reviewed at the start of the presentation where the complexity of private clouds was rated as the top concern, right? The costs, operating costs associated with the complexity, the skill set. That was the top concern that customers had with private clouds. And in our model, we do a lot of the lifting in terms of the control plane, the management fabric. The idea being it's a lot like Amazon Web Services, but for your hardware, for your environment. And you control what hardware you use, you control where the data lives, you control what APIs you're dependent on. It's open source APIs. So you're not locked in to some proprietary system that doesn't scale well for enterprise use cases. So that is really the core value proposition of Platform9. And in a nutshell, it's a lot simpler than traditional deployments. We'll go back and take a look at that demo again, see that it has indeed completed. But if you look at the y-axis, private cloud projects, when I speak to customers, I met customers who've been working on a private cloud project for 9 months. I'll give you specific names, Electronic Arts. Over here, Thomson Reuters, if someone knows them locally, I know that they were working on a private cloud project for 18 months. That's crazy, right? You can sign up for Amazon and use it in 5 minutes, right? And how can a private cloud be competitive if it takes 18 months just to get it up and running? So the idea behind Platform9 is we want to bring some of the goodness of the public cloud to the enterprise data center by bringing this OpenStack-based open source management fabric, but making it available as a service without the complexity. And as you can see in the user experience, you can get started with a Linux environment or a vSphere environment and be in production really in a matter of minutes. And then on the x-axis, if you look at what are we compatible with, we don't care what hardware you use, any compute, any storage, any network. We don't care what OSs you use. Linux is okay, vSphere is okay. And what virtualization platforms you use. You could use vSphere, you could use KVM. We'll support Docker as well. And it's all open APIs. So what's the catch? Where is the catch? Right? There's no lock-in other than us being a great way for you to run your private cloud, right? So I just want to quickly go back in and check on the demo. And being a live demo, it sounds like I am having Murphy's luck. We'll give it a couple of minutes more to converge because I am on a remote network, and we'll need to see if it does take a little longer. But
how do you deal with performance issues and latency issues you provide as a service?
yeah, so the beauty of the architecture is that the latency and performance is not as much of an issue, because if I go back here, let me quickly just walk you through the architecture one more time.
You see what I'm saying, that if I manage the environment, I know what I'm going to give the user.
Correct.
If he asking for too much, I say, okay, I don't have the capacity to do it.
Correct.
If I give to self-service, everybody will get whatever they want. How do I be able to
So I'm switching to a different environment here, which is a more lived-in environment. So the idea is that when you give access to capacity, the concern is how do you ensure that you're giving them checks and balances, right? So the key thing is that you can limit them by quota. So I want to just show you a test organization, right? So let me say this is a development group somewhere. You can limit what resources this group has access to, how many CPUs, how much memory, what storage devices. You can control any or all of these. So it's not like you're giving them a blank check. You can control it, but you don't have to be involved in provisioning every machine by hand. So the template is made available, and you've given them a sandbox in which they can play and they can be productive subject to the capacity that you made available to them, right? So that's a way for you to scale and for them to have immediate access to capacity as long as they're playing within the agreed upon capacity. So you'd agree upon a contract, essentially.
And also, I mentioned to you about the network as a service. That also tied to the VMware edition that you have. Because some of them don't have distributed switching.
So the question is network as a service, and is that dependent on the VMware edition? And I think that's a good question, sir. So there is a default behavior that works out of the box with a VMware VDS, which is the VMware vSwitches and distributed vSwitches, which are very common. But I think certain more advanced functionality, like load balancing as a service, if you want development groups to be able to log in and spin up a load balancer for a certain test functionality, that does require VMware NSX or another SDN solution. The choice is yours, but it does require a more advanced SDN solution. On the Linux side, there is a basic system that's already built out of the box with Open vSwitch. So you're absolutely right. Some advanced functionality does require a more sophisticated vSphere SKU. So you may need to deploy something like NSX for that. But did I answer your question on the tenancy encoders? Any questions on the feature set, folks? So let's go back in and check on this one last time, and it's probably going to take a couple of minutes, but you can come swing by the booth that I have there and see it in action. But essentially, it comes up in a matter of minutes, right? And that's the whole beauty of the system is you can go from an existing environment to having a private cloud platform that's orchestrating that within minutes. And it's very non-disruptive. So the design is such that you can continue to operate using vSphere or using OpenStack. There's no assumptions on any one being the only method of control. So that's a quick summary of the demo, folks. So in a nutshell, please come by the booth. I'm available for more Q&A. You can go from your existing Linux or vSphere environment to your own private cloud in a matter of minutes. In like 30 minutes is what we say. It takes less than that, right? And sign up for your trial. Find me at the booth, and I'd be happy to talk about next steps. And thank you so much for coming. And Deltaware team, thank you so much for having us.